In Unit 3, the biggest thing that I would say that Unit 3 was about was proving two triangles were congruent to each other. We had congruent polygons. We started off in 3.1 talking about congruent polygons, so 4-sided, 5-sided, 6-sided shapes. But then if you look at what we did in 3.2 and 3.3 and even 3.6, we spent a lot of time on 3 different sections. How do I prove that two triangles are congruent? And there were 5 postulates or theorems that prove congruency. The first 2, SSS and SAS, side, 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 and side angle, side, could prove two triangles congruent. And what they had to have is they had to have a side angle side congruent to another side angle side in another triangle. 2 pairs of sides, 2 pairs of angles, and 2 pairs of other sides, and that angle had to be touching both of those sides if you were using side angle side. Or side, 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 side had to be congruent to prove two triangles congruent. We also had angle, side, angle, and angle, angle, side. And we also had something called HL, the hypotenuse leg, for the postulates and theorems. There were 5 postulates and theorems, bless you, total that you could prove two triangles congruent. During these lessons, I tried to remind you that you could not add any congruent marks or arcs to a drawing unless there was a shared side. If there was a shared side, you knew that by the reflexive property that you could add a congruency mark. Never add any congruency marks unless it's a shared side, unless the angle's exactly the same in both by the reflexive property, unless there are vertical angles, and unless there are congruencies because of midpoints. If you're given that something is a midpoint, then you can say that two things are congruent. By the way, other things that were in here. Once we proved that two triangles were congruent, then we could use something called CPC-TC. It was short for something. It was short for the corresponding parts of congruent triangles are congruent. What we were doing this whole chapter about was if I could prove that this triangle is congruent to this triangle by one of the 5 postulates, then we could use CPC-TC to say that their parts are also congruent. And this was extremely helpful when we got to the proofs. This chapter, there's a whole lot of proofs, and we had to give reasons why we knew certain things were true. And this was something that carried on. You saw proofs in Unit 4, in Unit 5, in Unit 6. And so proofs are going to be, there's going to be a lot of proofs even in this final review packet. You'll see a bunch of them, and you're going to have to give reasons why you believe something to be true. Remember, we have 5 postulates here that you could use. SSS, SAS, ASA, AAS, and HL. And that's going to help you fill out the proofs. The proofs in the packet are going to be similar to what you could see as far as a proof on your final. When I look at your final will have proofs, but because it is multiple choice, you will look through your final and you're going to have to pick, well, is it this reason? Is it this reason? Is it choice C? Is it choice D? What's the reason that goes in that blank? And all of your popular choices will be there. Is it vertical angles? Is it alternate interior angles? Are they corresponding angles? Is it the SAS postulate? Is it the SSS postulate? Is it the ASA? Is it AAS? And you're going to have to know which one it is. There is no partial credit. It is 100%. Did you get it right or did you get it wrong for the final? The good part about your final, of course, is that since it is multiple choice and it's on Scantron, I can scan it and I will know what your grade is usually by the next period by the next class period. I don't ever scan the finals while you're taking the final. I used to do that, but I don't do it anymore. Instead, when your class, the first period, is done with the finals, what I will do is I'll take all your Scantrons, and while the Unit 4, Period 4 tests are starting their finals, I will grade yours during the Unit Period 4 final, and I will, you'll know your grades in Zangle by the end of that day. I will post it on the door for you if you do not have a cell phone to check, but it will be in the computer and so on. So your joy or your sorrow will be all you'll get to know that day. I promise you. Yes. The only other things that are in this unit, besides proofs and the 5 ways to prove congruency, shortcuts, were isosceles triangles and equilateral triangles. If 2 sides were the same, then 2 angles were the same for isosceles triangles. That was called the isosceles triangle theorem. We also knew that if 3 sides were the same, then 3 angles were the same, and vice versa. The only other things that we literally had to do was we had to pay attention in case there were overlapping triangles. If there were overlapping triangles, sometimes there's a shared side, and it's hard to see it when they're overlapping, but if you spread them out, a lot of times that will help. When there's a shared angle, sometimes it's hard to see it, but we use that even in Unit 6. Lastly, in Section 8, we talked about transformations, whether it was a translation or a reflection or a rotation. Those objects were the exact same size and shape as the original. They're still congruent because of these 5 postulates. And so these are not dilations. They're still congruency. That's why it was thrown in here in Unit 3. And that's where I'm going to end your Unit 3 review.